A thermal management system is an equipment like we have here behind me, or a combination of equipment that use thermodynamic cycle and only electricity for satisfying the cooling and heating requirement in a building or in a process. If you look at traditional design for heating and cooling system in a building, it's based on two separate systems. On one side, you have the heating system, and the heating system is based on boiler. So you burn fuel, gas for producing the heat. On the other side, you have the cooling system, is based on chiller. And these chillers are completely disconnected from the heating system. With the thermal management system like you have here, you are connected to both sides of the heating and the cooling side. That means we can benefit from the recovery from the cooling side for satisfying partially or totally the building requirement in terms of heating or domestic hot water production. Most of the buildings, they require heating and cooling. Simultaneous need depends really on the type of building. But you have building where you have a lot of potential for recovering the energy. For example, to hospital. In an hospital, you need cooling, whatever the period of the year. And during the winter time, you need heating. The same in the summer. Even if you don't heat the building itself, you need to produce sanitary hot water for the hospital. So there is a huge potential for recovering the heat from the cooling system for satisfying partially or from time to time totally the heating requirement of a building. So let's take the example in the industry. This unit can operate in heating mode, cooling mode, or heat recovery mode, and can combine the different modes. In fact, there is 3 heat exchangers on this unit. One of the heat exchanger is connected to the cooling side, the other one is connected to the heating side, and we have an air heat exchanger. This air heat exchanger is used for balance the difference between the heating demand and the cooling demand in the building. With the air heat exchanger, we can satisfy, I would say, what is missing in the building. Meaning we can reject when we have too much cooling demand in the building, we can reject the excess heat. When there is no enough heating in the building that can be recovered from the cooling side, we can extract it from the air. Business benefits is mainly in terms of efficiency. With this type of system, you can reach 300%, 400% efficiency. So that means you can improve the efficiency and reduce the operating costs. On the top of that, you are reducing your carbon emission. Something that will improve the efficiency of the thermal management system is combining the thermal management system with storage in the building, heating or cooling storage. Because you can store and harvest the energy when the building doesn't really need it and use it for later. An additional one, and I think it will be really the future, is AI. Combining AI, meaning getting data from the building regarding the building occupancy, the building behavior, with the thermal management system and the storage will tremendously improve the efficiency in the building.